Hey everyone, my name is Young, member of the Teen Advisory Board at the Howard County Library System, and today I'll be talking about data structures in Java. This might take a little while, so I'm gonna go really fast, but hopefully you guys can follow along. So this is our agenda for today. Let's just dive straight into it. So, what are data structures? Data structures are structures in code that store data. It's really intuitive. An array, like the one that you're used to seeing, is an example of what a data structure is. And different data structures can store or access data differently. And there are a bunch of examples listed here, but there are going to be 4 that we're going to be talking about, including array lists, right? Starting with array lists. So, array lists are essentially resizable arrays, and they're really similar to Python lists if you've done Python before. You're going to simply import it with import java.util.arraylist, and you're going to instantiate it with arraylist, and then the data type, and then whatever you want to name it, and then the rest of the syntax you could kind of just copy. And one important thing to note here, inside data type, you're actually going to need to type out the full name of the data type, right? So if you're going to do integer, you can't just get away with doing int like you're used to doing. It has to be the whole integer. So you got to type out the whole thing inside of the thing, inside the little, I guess, hairpin looking things, and then you'll get the you'll be able to instantiate it. So that's basically how array lists work. And when I say they're resizable arrays, I'm saying that you know how when you classic Java arrays, when you declare one and set the size equal to 5, you can't go anywhere higher than 5, right? The length is always going to be 5. But with array lists, you can actually just add on more elements to the end and just increase or decrease the length of the array list. So they're just in general more flexible. And here's some Arraylist methods. So you can do the .add method to add an item onto the array list, and that'll add an item to the end of the array list. You can do get to get an element, and the parameter that you're going to pass in is going to be the index that you want to get. The set, the first parameter that you're going to pass is the index of the element that you want to change, and then the second parameter is going to be what you want to change it to. So if I do set 07, that's going to set the 0th element of the array list to 7. Remove just simply removes whatever element is in the index position. So remove 0, remove whatever is of the first element of the array list. Clear just wipes the whole entire array list, so that'll just gonna erase everything in the array list. And the size method returns the size of the array list, so how many items are in it, right? So here you have a quick example. I encourage you to pause the video and try to see what it'll print by yourself. So hopefully you tried that, and this is what it prints. So you first instantiate an array list called numbers with integers, right? And we're going to add in the integers 5, 3, and 7, and then we're going to print numbers.get1, which refers to the first index, which is this 3, because Java is 0 index, not 1 indexed, right? So we're going to print out 3. And then we do number.set19, which will set the element in the first index to 9, which is at 3. So we're going to change 3 to 9, and then we're going to print the same thing, the first element, which is going to bring out 9 because we just changed that. And then we're going to remove that element, so remove 1, so pop it out, and then we're going to print the size, right? And originally it was 3, but now we popped something out, and now it's 2. That's why it prints 2 here. And then we're going to do system dot, oops, not that. So now we're going to run a for loop, and numbers.size is now, 2, right? We saw that. So it's going to basically go from 0 to 2, and it's going to basically grab the ith element. So it's going to grab the 0th and the first element of that numbers array list. And it's going to print it out, which is going to be 5 and 7, because remember, we popped out that middle element, right? So that's why it prints 5 and 7 here. And then we're going to clear the whole entire array list, and then we're trying to print numbers.size. The array list is gone, it's cleared. It's not deleted, but everything inside the array list is deleted. So because that's gone, numbers.size will just return 0 because we have nothing in the array list. Next, we're going to talk about hash maps. So a really easy way to think about hash maps is like a dictionary, right? If you ever use a dictionary before, you have the word and then what the definition is. So if you're going to search with the word water, right, the key would be what we call the or the word water will be what we call the key, and then the definition, for example, like a transparent fluid, right, that'll be the value of the key value pair, as we like to call it. So hash maps store items in these key value pairs, and you want to import the hash map with import java.util.hashmap and instantiate it using this kind of code format here. It's a lot. And the data type, same thing here. You're going to type out the full thing. So Again, if you want to do strings, you're just gonna type out the whole thing string, which you're probably used to doing. And integers, again, you gotta type out the whole integer. The first parameter here, or it's not really a parameter, but the first data type that goes in here is gonna be the data type of your key, and the second data type is gonna be the data type of your value. So the key is gonna be, again, that word or whatever that's gonna be referring to the value. And here's a nice diagram. So you can see here each key corresponds to each value, and so on. And this is similar to Python dictionaries if you ever used Python before. So here's some methods you can use with hash maps. So you can do this put method, and the first parameter is going to be the key. The second parameter here is going to be the value. So we're going to put in a key value pair, which is chicken and 2, into our hash map. Get, you pass in the parameter as, or you pass in the parameter, you're going to pass in the key of something. You're going to pass that in, then it'll return the value of whatever you passed in. Remove, you pass in a key, and it'll remove the key value pair of whatever that key has, right? So if we do remove chicken, that'll remove chicken and 2, which we just put in. Clear, same thing with Arraylist, it just clears the whole entire hash map. And size returns the amount of key value pairs inside of the hash map. So again, here's a quick example. I encourage you to look over it. Hopefully you try to find stuff at this point, so let's look at the solution. So first we instantiate a hash map with string and integer, right? So the key is going to be strings, the value is going to be integers, and we named them animals. And we're going to put in chicken 2, cow 5, pig 3. So the chicken, cow, pig are all what we call keys to 2, 5, 3 are what we call values. And each of them are correlated with each other, or corresponding to each other. And this is what I call a modified, oops, not that. This is what I call a modified for loop with this colon thing. And animals.key set, this whole thing is referring to all the keys of the animal's hash map, right? Which are chicken, cow, pig. And basically what I'm saying, by doing this, we're saying for every string of the keys, and because the keys are strings, right? Chicken, cow, pig are all strings. So for each element of that, we're going to print out animals.get I. And what is I? I is the string of chicken, cow, or pig. And when we do animals.get that, we're just going to end up printing the numbers, right? The values of the key value pair, right? And then, oh, well, I should probably load up the solution. Yeah, there you go. So when you do that, you're going to get 2, 5, and 3, right? Because chicken corresponds to 2, cow corresponds to 5, pig corresponds to 3. So that's how you're going to get 2, 5, 3 printed out here. And then we're going to remove pig. So pig is gone. And then we're going to do animals.size. Originally it was 3, but now that pig is gone, there's only 2 key value pairs in the hash map. So we're going to print 2. And then we're going to do that same modified for loop after we clear the hash map. The hash map. And when we clear it, all the key value pairs are gone. So when we try to iterate through all the keys, there are no keys to iterate through. So essentially this prints nothing. So now we're going to talk about stacks. So stacks are based on the concept of last in, first out, which will make more sense when I describe what they really are. So imagine a bookshelf, right? Or not a bookshelf, like imagine like a stack of books, and they're in like a box, so you can only access the top element of the stack, right? You can't just pull out a book from the middle, right? It's blocked off. And that's basically what stacking programming is. You can see this diagram here. If I want to access a book that's like on the bottom of the stack, I'm going to have to pull out every single book from the top to get to the bottom of the stack, right? And that's last in, first out. The last book to go in, which is obviously going to be on the top of the stack, is going to be the first one to go out whenever anybody wants to do anything with that stack. To import it, we're going to do import java.util.stack. Instantiating, same deal. Again, data type, passing the full thing, integer or string, whatever. And then you're going to do the whatever stack name you want to name it. And here's an example. So stack string. So this is going to be a stack full of strings, and it's going to be called books. So here are some methods. So there's a push method, which will literally just push a string onto, or not a string, well, any element into the books or the stack. And to access the item, you can do the peek method, which will look at whatever the top element of that stack is, and only the top element. Remember, in stacks, you can only do stuff with the top element. The pop method literally just pops the top element out of the stack, right? Only the top element. You can't pass in any parameters here. Again, with stacks, the only important thing is that top element. Now, the empty function, or method, checks if the stack is empty or not. If it's empty, it'll return true. If it's not, it'll return false. It doesn't clear out the whole stack like Arraylist for hash maps. Now, the search method is a little weird. So it's basically going to search the whole entire stack for a book, or like, I mean, in our case the book, but it's gonna search the whole entire stack for whatever element that we pass in as a parameter. In this case, we passed in wonder, right? But it can be a number, it can be a string, whatever, right? So once you pass that in, it's gonna search the whole stack for that thing, and if it finds it, it's gonna return how, like, from the top, how many books down or how many elements down that element is located at. So for example, if that element was located at the top of the stack, it'll return 1. If it was a second from the top, it'll return 2. If it was third from the top, it'll return 3. If the element doesn't exist within the stack, it's going to return -1. So again, take a look at the example and try for itself. So hopefully try it for yourself, and let's look at the solution. So we instantiate a stack of strings called books, and we're going to push in wonder, and we're going to push in Fahrenheit 451. Now Fahrenheit 451 is above wonder, right? That's why when you do books.peak, it's going to print out Fahrenheit 451 because that's the top book, as you can see here, right? And then we're going to search for wonder, where, well, wonder actually exists. It's a second book, right? Which is why it prints 2 when we search it. And we're going to search for Don Quixote, but Don Quixote doesn't exist. We didn't put that in our stack. So that's why it's going to print -1. Because whenever something doesn't exist, when you search, it's going to print -1, right? And then we're going to pop. So what that does is it's going to pop that top book, which happens to be Fahrenheit 451. So we pop that. So now the stack only has wonder, right? And after we pop, we're going to do, is the book stack empty? Well, we still have wonder in the stack, so it's not empty. So it prints false. And then we're going to peek. So that's going to look at the top element of the book stack, and that's wonder because that's the only book we have in the stack. And that's why it prints wonder. And then we pop that pop that last book off, so now our stack is completely empty. And we're going to check if it's empty by doing books.empty, and it's going to print true. So finally, we're going to talk about queues. So queues are a concept of first in, first out. Think of this as a line. Like, you know, if you go to the amusement park, you got to line up for like the 30-minute long line, and then only for like the 2 minute of joy, like 2 minutes of joy. Like, that's basically what a queue is. It's a line. You want to import it with import java.util.queue, and you're going to instantiate it with queue, and then the data type equals new linked list or anything. You can search, I mean, not anything, but you can search up. So basically what a queue is, it's an interface. A queue is actually an interface. And you're actually going to have to declare an instance of the method by using a class that actually utilizes the queue interface, right? We just talked about interfaces, so the linked list class just happens to be utilizing the queue interface. There are other ones out there. You can always search up like how to implement queues, and then there'll be a bunch, like a list of bunch of classes that implement the queue interface. But queue is essentially an interface. That's why you can't do queue whatever equals new queue. You can't do that because you can't instantiate an instance of an interface. That's just not possible. And same thing with the data type, passing the full thing. So here, for example, we're gonna call a queue, a string is called line, equals new linked list, which is again a class that implements the queue interface, and we're gonna obviously make it full of strings. And here's a quick diagram, so you can see here it's like a line we insert from the rear and then remove from the front. So here's some methods. You can add to the queue, which is gonna add stuff to the end of the line, right? It's gonna add to the end of the queue because again, it's first in, first out. And then peek will, similar to stacks, it'll look at the first element, so whoever's at the top or whoever's at the front of the line or front of the queue, it'll peek whatever's there. Pull will remove the frontmost item out. It'll pull it out of the queue. So with queues, you can do stuff with either the last thing or the first thing, right? And here's an example. Again, as always, I encourage you to pause the video and look over it. Let's go over it. So we're going to instantiate a queue that's going to be full of strings, and then we're going to add Descartes, Euler, and Leibniz. These are mathematicians. And then we're going to print line.peek. And because we added in, let's see, Descartes first, that's what we're going to print. And then we're going to pull, which will pull out Descartes. And then we're going to print, we're going to peek again, and it says Euler. And then we're going to pull out Euler. We're going to peek again, and now the last one in the line is Leibniz. And when we do that, it's going to print Leibniz. And then we're going to pull Leibniz. So now the queue is empty. And when we try to peek again, it's going to say null because, well, there's nothing to peek at. So finally, we're done. So that was a lot of talking. So thank you for watching. Watch out for future videos. Like and subscribe. Follow our Instagram at chspyoneers. Check out our website. And then email us for questions. I promise I'll respond to all the questions. And I know this was a really fast one, but hopefully you can pause and slow it down or even search up stuff related to data structures. or ask me questions about them. I'll be happy to answer them. So thanks for watching, and I'll see you guys next time. Goodbye.